This right here is a late 1940s Cauffiel motor, model 4000, made by the Cauffiel Motor Company in Toledo, Ohio. Not very many people will know what this engine is by first glance at it, but here in a second I'm going to show you side by side by an engine that some of you will probably either own or have or seen somewhere else on my channel or you've had yourself, that it'll look very similar to. And some of you might already notice the similarities already. So I'll bring it to the side here, and you will see here in a second that this engine right here looks very similar to a 1940s Clinton 700A engine. The reason being for that is this Cauffiel is made by the same guy that designed 4 Clinton engines, the Clinton 700A block, the original Clinton engine. Lowell Cauffiel, the guy that made these engines right here, originally in the 1946, Clinton Machine Company hired him to design an engine they could make because they wanted to make an engine. He ended up making the Clinton 700A, which Clinton ended up selling millions of. After making the engine for Clinton engines, he ended up seeing how well it went for sales, and he ended up making his own, which is the engine you see here. This is a Cauffiel motor made in the late 40s. And the biggest difference between the two is the one is all aluminum, while the Clinton is solid cast iron. Now, the biggest flaw of these engines is the fact that when they made these, it was made in a garage in Toledo, Ohio by a group of guys instead of a full production machine company like Clinton's were. So there's lots of crude parts on this. I believe they even cast them in-house, so the castings aren't the greatest. And when we dive deeper in this engine as I redo it today, you will see that there's some specific things inside that weren't the brightest ideas back in the day. And I haven't even been in this one very far. I took the pan off before the video just to see if my insides are okay, because these have a tendency to have bad internals. So I checked, all my parts are good inside, so I'll be able to finish this video. But depending how the upper end of this engine goes might show you just the low quality of these engines that this has. We might have some interesting stuff under this head here. So what I'm going to do today is one of my standard videos pretty much, except for I might do a little bit more talking about this in this video if something comes up that I want to talk about. I'm just going to tear this all the way down. I'm planning to get all of this paint off of this motor because whatever this paint is isn't very good, and if you can't tell from the front, the logos it has definitely aren't original and don't look very good. So I don't know how well this camera's picking it up, but if you can see on this engine, when they built this, it looks like this one has seats, but I can't quite tell without those valves out. I'll find out later. But this sleeve in this aluminum block only goes up to here. There's like an 1/8 inch where that sleeve is not there. And there's a giant dent right here where I'm assuming they crimped that sleeve in with. You can see it better on this side. There's a step right here where it doesn't even go up there. That sleeve is just missing on the top half of that block. So that's kind of neat. So I don't know who last messed with this, but they messed up the end of this nut on here. At first I thought it was different from a Clinton, because Clintons are always 5/8 sockets to get the nuts off, but it's just rounded on the end, so I'm gonna have to get a hammer and beat this on. There we go. That didn't come off very willingly. Probably gonna end up replacing that nut completely. The end of that crankshaft's all messed up. I'll have to fix that. That's why that nut came off pretty badly. Pretty scuzzy in there. Not the worst I've seen, but it's definitely not great. Flywheel is almost identical to a 700A. If you've ever worked on one, you'd see that that's very, very similar. And yes, this is the same ignition system that a 700A Clinton has. Almost everything on this engine, besides the fact that it's aluminum, is the same as a 700A engine. So, there it is. Bendix. Yeah, these normally aren't that hard. There's your rotor for your magneto. Unlike most air-cooled engines, the Clinton 700A and these engines here, as well as some other Clintons, all have a scintilla mag, and the early scintilla mags have a rotor in them instead of using the flywheel as the rotor. So you can actually test spark on these engines without a flywheel on, which is really handy. So, got all 4 of those screws out. Let's see if this comes off easy. Oh, that was real easy. And there's the all aluminum backplate. It does have a bronze bushing inside of it. I wasn't sure if I'd expect an actual bushing or if it was going to be aluminum on these. I'm never sure what to expect on these motors. It's even got an aluminum valve cover. It's a really weird breather guard compared to a Clinton. If you really think about this valve cover, this is more time and effort than it would be to get the steel one, because all the steel one is just a piece of plate steel you could have put on here, but they took the time to cast and machine these with fins in it and then surface it and drill a hole through it, which is kind of impressive. There's extra work into this, but there's also lack of work in other parts on these motors. That oil pan is dry. This has part of a centrifugal clutch left on it, which I'm surprised somebody actually tried to put this on something that needed that, like a scooter or go-kart, because these do not have good power, and if you tried to put them under a load very long, I imagine they blew up pretty easy. But here we are with what's left of one. And I don't know a lot of history on these engines because there isn't really much of it around. This could have came factory on a scooter too, because this clutch has been on here a long time. In which case I feel bad for that scooter to have something like this on it. There we go. Swing. Hold like that. And here's. It does not appear there's a set screw in it. There's a spot for one, but there isn't one. So I'm going to see if I can get a pulley puller on this and pull it off. Just remove. Gotta change my jaws around too long. And there we have a pulley. What's left of it, anyway. It does appear there's writing on it, so I wonder if it's a Comet brand or not. When they put that on, they put some washers on here so it wouldn't hit the block. Kind of an odd way to do that, but that's it. Okay. So there's the oil pan. Looks almost identical to one on a 700A. It's really cool. So there's your dipstick, there's your slinger. It's just a giant point. Pretty simple. Here's the piston. It looks pretty much exactly like a 700A piston, nothing really different about it. But if you look at the rod, you can see it's kind of a weird texture to it. It's like really shiny too, and like really crude looking. Almost looks like plastic damn near, except that it isn't. And this whole thing, this whole piston and rod is really light. Like, it isn't like normal aluminum from a Clinton light either. It's like really light. So I don't know what aluminum they used on this, but it's very, very light. There's crankshaft. Looks exactly the same as a 700A crankshaft. Nothing odd or different about it. No part number is the only real difference. There, the valves are out. They look like a generic valve. I see a logo on them, so I don't believe these are made by Cauffiel. I believe these are bought from a generic company. They might even be the same valves in 700A because there was companies that made them back in the day. The retainers, on the other hand, they look like they were made on a lathe by hand because there's a lot of rough finish on them. See if I can get the camera to see this. You can see all the lines from the rough machining, and every bit of it's square and not a pressed out piece of steel like most engines had of the era. So there's a lot more work into machining them like that, but there's also a lot more money into making a steel die that presses those into a pressed sheet metal. And that right there is now an empty block. The piston, when it came out, actually removed a chunk of the unused cylinder wall from where this sleeve didn't get all the way up there, so that ain't there anymore. But that ain't a big deal because that wasn't really doing anything to begin with. Another thing to note on this one that I'm going to talk about right now is that these valve seats are steel. There is inserts there. So there is an actual insert put into this one. The last one I worked on didn't have those. It was just bare aluminum. There was no insert or nothing. This also has bronze bushings for the valve guides, which is kind of neat. I don't believe the one I did last time had that either. And then this cam, if you can tell on camera, I don't know if you can tell. I'll get you guys zoomed in here. That cam gear is aluminum, but it has a insert for the cam lobes that's steel. The last one I worked on, that was one solid cast aluminum piece. All the lobes and everything were one casting with the gear. So this engine here is a lot better quality build than the last one I worked on. So, got all of it apart. I'm going to lay it all out, and I'm going to talk about how I'm going to deal with some of the stuff on this, and we'll move on to start cleaning some things. Okay, so I got it all laid out here. Nothing's in bad shape, which is a good start. I believe I mentioned at the beginning of the video, the first thing I saw on this that was actually bad is the carburetor's missing a needle, but I have extra carburetors over there that I can use for that. The ignition looks pretty good for what the ignition is. These ignitions have a real common problem of having a coil go bad. The piston and rod look pretty good. They're a little scuffed up, but they'll clean up good enough for what I'm going to do with it. The block looks pretty good. I'll redo the valves and seats in it, so I'm not too worried about that. The sleeve isn't scarred up. I'll have to hunt it because it's pretty rusty. The biggest thing on this whole engine when I bought it was just how bad the paint job was on it. All of this scuzz and stuff that's on this stuff. I want to get it off and get this back down to bare aluminum because it'll look better than what's on it now. Once this is all down to aluminum, it'll look a lot better than this blue and marker that's on it right now. The quality of how they made these engines is real abundant on the shroud, because if you look here, this notch right here is factory. Everyone I've seen made has this on it when it has the air governor, and you can see where they cut past where they were supposed to cut with the hand snips, and they just cut this out by hand back in the day. And I almost bet that the die that was used to make this was a piece of wood that went through a hand-carved form. So to actually distinguish what dents are later dents than new dents is kind of hard. But I'm going to try and true it up as best I can. It's aluminum, so it's hard to get all the damage out once it's dented. But I'm going to coat the shroud in paint stripper as well as the block and let it sit. The carburetor I'll do a standard carburetor rebuild on, and the rest is just basically needs scrubbed down because paint comes off aluminum pretty easy. I can scratch it off with my fingernails, so hopefully with just a little bit of paint stripper sitting for 15 minutes, this will all come apart pretty easy. I got them all paint stripped down now. They look a lot better, but they're still not quite right. The shroud has a lot of like grime left on it, so I'm gonna have to hand buff that. You can't really scrub it with anything because the aluminum will leave a horrible finish. If you take steel wool to it, it'll scratch it all up and stuff. So I'm gonna have to see if polishing compounds will get this out, the real fine stuff. The block itself, I got most of the rough paint and the dirt off of it, but it still kind of has a blue hue to it. So I'm gonna end up taking and plugging off the bearing surfaces and the bore, and I'm gonna blast this lightly with the sandblaster to clean it up its final little bit, because these veins are all dirty inside and stuff. That'll make that look a lot nicer. I'm gonna do the same thing with the back plate so it matches, as well as the head and the base. I didn't even bother cleaning up the base because I'm gonna just wash it down quick with some kerosene to get the big chunks off and blast the whole thing. There's no surfaces on it I'm worried about ruining. Okay, so I got them all blasted and I buffed them up a little bit so they look pretty nice. I'm not gonna have time today to work on the shroud, so I'm gonna have to do that in the next video. I'd say everything turned out pretty nice. It's all nice and relatively shiny. It's not very smooth, but the castings aren't very nice, so that's expected, but it'll look better than the paint that was on it. This is all I have time for today for this video. If you want to see the rest of this, subscribe. I'm gonna hopefully upload that next week, if not the week after. I just had a month of being sick because we caught a bunch of different bugs going through at work, and this is the first weekend I felt nice enough to make a video, so I'm finally getting around to this one. I picked this up in October, and I've been meaning to get around to getting it fixed up, but it took this long to get to it. So if you liked this video, leave a like. If you didn't, I wouldn't think you'd make it this far. If you want to see more small engine and hit and miss engine related content, please subscribe. In the next video, I'm hoping I'll just get the shroud all buffed up, the carburetor went through, and everything else cleaned up. We'll reassemble it, and hopefully it runs pretty good. So, see you later.